All right, good morning for pre-calc. We are going to start on chapter 11 today, and we'll do a little bit of theory stuff, and then we'll get into doing some problems again. Okay, so we can make sure that that's happening. All right, so this is, it's funny, it's not really pre-calc 1. This is like pre-calc 2. Because most of the topics that you see are going to be coming back to you in Calc 2 and not necessarily in Calc 1 so much. So you just have to remember everything you learned for a year, and then you'll be fine. Sure. All right. So actually, it does come back a lot easier than you think it will, so it'll be okay. So sequence, this is just a list of numbers. We're not going to do anything with them. We're just going to note a pattern, and we're going to write some of them down. Okay. One thing we do want to deal with is that, like usually we have an f of x. In this case, we're going to have an f of n, so we could say a of n equals, and then come up with like a 2n minus 3 or something. So they're kind of like a function, except the domain is going to be the natural numbers. Okay, so our domain is going to be natural numbers. The range can still be the real numbers. Okay, the range is untouched. Because if I wanted an a sub n is equal to, say, the square root, right, of ai or something, as I is going from 1, 2, 3, dot, dot, dot. I mean, this sequence is going to look like 1, square root of 2, square root of 3, square root of 4, which is 2, square root of 5, etc. So we're not restricting, right, our range to being natural numbers because clearly these aren't. Okay, and that's fine. So yeah, a little bit of notation. Typically, I think your book kind of defines everything with the little brackets like this, the curly brackets. So we might do something like n plus 1 and then like a 2n. All right, and if I wanted to just write out, right, I would say n is equal to 1, n is equal to 2. We might have n is equal to 1. You could say infinity up here. That's okay. Okay, that just means that the sequence is infinite. We have infinite sequences. And when you get to calculus, this is most of the operation you're going to be dealing with is infinite sequences. You can also have finite sequences. Okay, that's okay too. Okay, I have a pretty devilish finite sequence. I have to look it up though. But most of these are, one of my math teacher, he called these IQ tests because you get a pattern and you're supposed to turn what you have here into a pattern. So negative 1 to the n plus 1. And here they give you the pattern. All right, so negative 1 raised to the n plus 1. We do the exponent part first. So that's going to be 2. Negative 1 squared is going to be 1 times 2. And our first value is going to be 2. And it really is that straightforward. So this is negative 1 to the 2 plus 1. And we have 2 to the 2 here, 2 times 2. This is an odd number, so it's going to be negative, and then 2 times 2 is going to be 4, so we end up with negative 4. Okay, n is equal to 3, we get negative 1 raised to the 3 plus 1, okay, and times 2 times 3. That's going to be an even power, right? 3 plus 1 is 4, so negative 1 raised to the 4th power is going to be positive, so we're just going to end up with 2 times 3 is going to be 6. And I think after that, people could probably pick up, it's 2, negative 4, 6, negative 8, 10, etc. Okay. You have to be careful. Excuse me. You don't want to be too cavalier in deciding what a pattern is because you usually need more than 3 numbers in order to decide a pattern. You can usually make an educated guess, and this book isn't trying to trick you into coming up with like the weirdest thing you can come up with. But if you play these games on the Facebook, hopefully you don't, but you know, I always find it amusing. I'm like, what's the next number in this sequence? And I was like, that's not, you didn't really give me enough information. So there's more than just those sequences that you've come up with, really. So just, again, just be careful about that, but not so much with the homework, because like I said, they're not trying to fool you. They're not trying to trick you. They're just trying to get you to guess a pattern. Okay. And there are often more than one answer. So you can't say, well, this one is the correct one and no others could be this. Like that's not really true. There's lots of things that can happen. So let's see here. The alternating sequences, we kind of talked about them here. Alternating sequences. Right, just alternate signs. Okay, usually you're going to see a -1 to the n, -1 to the n plus 1, like -1/2 to the n, because every time n goes to even, it'll, you know, there's one of these and plus an n to it. There's some stuff you haven't seen yet. If you're going to take trigonometry, you have something called a cosine, and it's abbreviated cos. And when you do that, it's a function. It's the cos of something. It's like, if you're going to write down the square root, like it's going to be the square root of something. You're not just going to write this symbol and leave it. Okay. So cosine of say pi, you'll learn this eventually when you get to trig. That'll be cosine of pi is -1. For now, just take my word for it, or if you've taken trig, you know. But n pi as n goes from 1 to whatever. That's another way of alternating a sign, okay, SIGN sign, since we're talking about trig, rather than an SINE sign, which is a different type of a thing. Okay, with cosines, we also have sines. Again, you'll get to that when you get to trig, but until then, that'll work. Okay, so just letting you know, there's other ways of writing alternating series than just -1 raised to a power. You'll see this as well. Okay. So yeah, that's pretty much that's a big thing about sequences. It's just a list of numbers, and we usually make a pattern so that people can get the next one, and we just kind of go from there. Okay, that's sequences are kind of, you know, that's pretty much all there is to write about sequences. So we can do a couple of homework problems with these, and let's see here. Just to kind of get us started. Okay, so here, right, so we'll start with number 2. We won't start with 1 this time. So this is 40 raised to the -1/8 raised to the n, and I just would like to see, well, how do we start this thing? So c sub 1, right, that's 40 times -1/8 to the 1 power. So that's just going to be 40/8. It's going to be -5. C2, 40/-1/8 squared is going to be 40/64. Now, let me show you. Let me pause so I can bring up my calculator. All right, so there we go with the calculator. They will want your answer in terms of a fraction. So if I'm going to go ahead and do this, I'm going to say 40 divided by, and we could say 8 squared, and there we have it. But they're not going to like that answer. So we're going to go ahead and we're going to hit this math button here. We're going to say convert to a fraction, and then go ahead and do that. So we end up with 5/8. Okay. C3, 40/-8 to the 3. So I know my answer is going to be negative because there's 3 of these. So you don't have to go ahead and dutifully put in every symbol into the calculator. You can kind of make a, well, this is going to be 40/8 cubed, and I'll apply the negative as I need to. And then we'll go with math, fraction on. So it's -5/64. So it's times 8, right? We're just going up by another 8 every time. One of the 8's cancel. So C4 right? Again, 40 negative 1 over 8, so it's going to be positive to the 4th power. I don't, what's 64 times 8? 512. So this is going to be a 5 over a 512. Okay. So if we go ahead and put those in the calculator, or put those in our answer here, what do I want to do? I want to go back to this. All right, so just to put this stuff in, right, this was going to be a negative 5. Okay, this was a 5/8. Okay, this was a negative 5 over 64. And then we had a positive 5 over 512. Check. Yeah, it seems like it's reasonably happy. Okay, so there we go. But really, that is that is the whole goal. That is the whole game here. Is typing these things in. You can see, as tricky as they get, right? There's really not a huge amount of tricks here. Okay, which are positive, which are negative, right? Well, you can write some of them out just to check. But if I put in a 1 here, that's going to be a 3. If I put a 2 in, that's going to be a 4. If I put a 3 in, that's going to be a 5. So 1, 3, 5, 7, 9, all of those terms are going to be negative. So the odd numbered terms are going to be negative. The even numbered terms are going to be positive. Okay. Be careful. Oh no, that one. Oh, that's really peculiar. Okay. There are sometimes where, like, they have these, and I noticed it was attempt 1 of 1, and that's all you get. And this one is attempt 1 of unlimited. Go figure. Okay, we don't have the ability, by the way, to like individually go through these questions and make sure that they, it's like you set the attempts for the entire assignment. We don't do, like, I'm not Mickey Mousing around with, like, well, this one should be like, no, we're not doing that. So this one's pretty straightforward, right? We just plug in 1, 2, 3. There's no reason to count this up to 102. We can just type in 102 here and be done with it. All right. So the next idea I'm trying to find here, okay, oh, the graph. Okay. So we covered this a little bit at the beginning, just talking about what the domain is, and just to make sure that you're getting the domain to be like 1, 2, 3. And then what's the shape, right? It's a square root function, right? You know what the square root function is, right? This is 1 over x. This is 1 over x. This is just a straight line. Good Lord, this is like a Facebook multiple choice. It's terrible. Okay. It's like there's one good answer and everything else is completely terrible. Okay, again, 3 over x. So we have this. Okay, 3 over x looks like we're going to get something here. Oh, but this one's with x. So to be careful, because this one, the domain is the real numbers. The previous one, the domain is the natural numbers. And that's the difference when you're talking about this one. Okay, so this one, we're going to, when x is 1. I don't like that. It's the only really answer I have here, but oh, square root of 3. Never mind. Yeah, we're good. Okay, so that's something to watch out for, but don't let them fool you with that. It's really tricky. But this will bring us to the next topic, okay, that we're going to have. Okay, so actually, you know what I'm going to do? I'm going to be clever. So I've learned this little trick today. So I'm going to say stop.